on Wednesday. We're going over now the last stuff. We're going over our next type of tissue, osseous tissue and bone structure. We're going to focus on cartilage and bone. So we're starting our chapter on cartilage and bone. What kind of tissue is it? Connective. Both cartilage and bone are a type of connective tissue. It's not connective tissue proper, so it doesn't fit under those 6 that we went over. But it all stems from what? All of it stems from which embryonic? Oh, mesenchyme. Mesenchyme, which comes from mesoderm. Right. So we're going to focus to start on cartilage and compact bone. The rest we'll go over later. So don't worry about that for now. When I talk about bones, when you think of tissue, your bone is made of living tissue. That's why if you break a bone, you can repair it. So bones obviously can provide structure, just like a frame for a house. But let's say you're trying to remodel your house. If you have a one-level house and you want another level, if your house is, you're living in it's intact and it's only one level, you want to build another level, what do you have to do first?
Build support.
You have to build support. So in other words, to remodeling implies that you're tearing stuff apart and then building more. Both of those processes are involved in making bone. You have to tear some stuff apart before you can make more. So we're going to see that happen. At a cellular tissue level, we're going to see that bone and cartilage are a lot like how a concrete is poured. To have really strong concrete, you don't just pour the concrete, you also have this rebar, those rods. That gives it strength and flexibility. Does that sound like anything we've talked about? What fiber has strength and flexibility? Strength and flexibility. Collagen, yeah. So this is like the bone, like the part of the bone. Your bone is made up of more than just cells and calcium. It's also made up of proteins like collagen. And then for this next quiz, we'll go over ossification, how the process of bones are made. What is bone made of? It's made up of several things. I'm sorry, we'll get to what it's made of in a minute. To protect and provide leverage. We know how to start with having an attachment for muscles so that we can move our bones. Bones in stomach?
Yes.
So this is the obvious function of bones and cartilage, that it provides support and protection. Another function of bones is a storage area for important ions, like calcium ion and phosphate ion. This is how you abbreviate calcium ion, Ca2+. You should know that. Ca2+ is the abbreviation for calcium ion. Phosphate ion is PO script 3- superscript. All that means, we're not going to talk about the chemistry too much, it's just how many, like this has a phosphorus and oxygens in it. This is made of calcium. The term ion means that it's something that can, it means a couple things. One, that it has a charge, the plus or the minus, and two, that it can be dissolved in something. Calcium and phosphate, that's what your bone is primarily made of. Like, so when you say you need calcium in your bones, you actually need calcium phosphate in your bones. Those two ions are important for more than just bones. They're really important for things like neuron function and muscle function. If you had to choose, what would you prioritize if you were low on calcium? What would you prioritize? Functioning of your neurons or functioning of your bones?
Neurons.
Neurons, that's what keeps you alive. So when you need calcium in your body, if you have low calcium in your body, you're going to take it away from your bones and use it elsewhere. Which is why if you're calcium deficient, you're still alive, but your bones get weak. Yeah.
So, like for osteoporosis, would you need more calcium?
Osteoporosis, would you need more calcium? Yes, you need more calcium. There's other factors going on with osteoporosis. Though. It has to do with the lack of hormones. At least that's what it's major cause of it. It happens typically in older women and that have gone through menopause and you have lower levels of estrogen. So estrogen has some role in maintaining your bones. A lot of bones play a role. Birth control affects hormones, and hormones that affect your bone density. So yeah, all that.
Brittle bone disease.
Brittle bone disease. Is that the genetic one? There might be a genetic condition, or is that something that you've been exposed to?
I think that's genetic.
If there's a genetic condition, there are tons of genetic conditions. That it could be problems with the cells in our building, with making protein. I'm not too familiar with that particular one. Yes. When people get older, the bones get smoother. In general, your body's starting to not function as efficiently. Cells are dying. I don't know that it gets, whether it's skin or bone or whatever. So if you break a bone, it takes longer to heal. So that I consider. I don't know about the smooth. Bones are also really important for producing blood cells. We'll be talking about bone marrow. The insides of some bones have the special bone marrow that produces blood cells, red blood cells, white blood cells. It's always changing. The bones that you have turn over in material every, like constantly, but you get basically a whole new bone every 7 years or something. We've been focusing a lot on cartilage and bone here, but don't forget that all these other connective tissues are also found in bone. We'll be talking about blood. Like I said, blood cells are made from bone marrow. Adipose is found in another kind of bone marrow. It's called yellow bone. Yellow bone marrow leads to adipose. Red bone marrow leads to what we find in blood. Tendons, ligaments, and coverings of bones. Bone sheaths. Sheath means a covering. A sword sheath is where you stick your sword. Bone sheath is covering the bone. That's all these things are made of dense regular. Tendons connect muscle to bone, lead to osteocytes. Chondroblasts lead to chondrocytes. That should sound familiar. Fibroblasts, fibrocytes. We'll be starting cartilage first. Cartilage, chondroblasts will be building an extracellular matrix that's kind of squishy. There are 3 types of cartilage, which we'll go over now. Where you find cartilage in lots of places, typically at the ends of your bones and joints. Other places where we see cartilage, remember the trachea, how it's kind of cushiony and those circular rings. And we'll also see its role in ossification. All these connective tissues come from mesenchymes and all these different types. Those connective tissues. Okay. Starting on cartilage first. Cartilage in general, we have chondroblasts. The way to identify a chondroblast is that it's towards the edge of cartilage. So you can see other cells that are deeper in and surrounded, those are chondrocytes. Chondroblasts, the immature ones, the ones that are building cartilage, chondros, the ones that are towards the edge. This extracellular matrix made of, it's mostly meats, even if you feel your own cartilage. You know it's squishier. It's not hard, it's hard as bone. So water makes it that squishy. But of course there's other stuff, it's not just pure water. The 2 things I want you to know are these 2 molecules. Collagen, as we've discussed, it's found in a lot of connective tissues, it's found in cartilage. And this other protein called proteoglycan. What that really means is protein with carbohydrates attached to it. Like glucose, that sounds like glycan, glucose. Proteoglycans, they make it very squishy as well. The collagen makes it strong and flexible. That's what most of this is in between. Proteoglycan? Yeah. Proteoglycans they're another protein with carbohydrates attached to it, and they make cartilage compress better. Gives it cushion. Unlike the dermis of skin, it does not, and also similar to the epidermis, does not have any blood vessels. It is avascular. If you tear cartilage, like if you've torn your meniscus, it doesn't heal very well. It's also aneural, so you don't feel pain in your cartilage, but you feel pain elsewhere surrounding it. It doesn't heal well, but it does get oxygen and nutrients. Let's say this is the end of a bone. Here's the lumen. This is a fluid-filled lumen. Can someone tell me what kind of fluid is bordering it? I know it's interstitial. It is interstitial, but what's a specific type of fluid called? Sorry?
Plasma?
Not plasma. That's only inside of blood vessels. Synovial. Synovial fluid all lubricates joints, but it also nourishes cartilage. It doesn't have as much oxygen and nutrients as blood would, as plasma would, but it still gives something. Which again, you've got your mitotic cells towards the edge. These cells heal very, very poorly. If you damage these cells, they're probably dead. Which is why if you tear cartilage like a meniscus, they usually just cut it off. Yes?
So when you get like your ear pierced, is it the surrounding parts of your ear that are causing you to have pain? When you get it pierced?
Oh, if you get your ear pierced, what's feeling pain? It's the skin part. It's integrity. The term for, so our cartilage growth slows in young adults. So if you tear cartilage now, this is why your joints they just don't work anymore. The outer layer where you find the chondroblasts, that's called the perichondrium. Peri meaning outside, like perimeter. This is the bulk of the cartilage. So, like what's saying, stretching. Yes.
What is this blood vessels help?
Right. So yeah, blood vessels help the perichondrium go this very, very outside. The chondroblasts are this layer right here. So let me repeat myself. Chondroblasts are bordering the blood vessels. The chondrocytes are not. So this cartilage here has no blood vessels.
So the perichondrium is
The perichondrium gets blood vessels, has blood vessels, but not the major cartilage part. Okay. That's what perichondrium. Is synovial fluid what's inside of a bursa sac? Yes. Okay, there are 3 types of cartilage, and you should know the different types. Hyaline is the first one. When you see a chondrocyte, remember a chondrocyte's the mature one that's surrounded by extracellular matrix. The way that you identify them is that you see the cell inside of a space. The cell is the dark thing, so this is our chondrocyte. The space is literally a space. The term for space is lacuna. Lacuna. So you see a bunch of cells with spaces. The cell is sitting in a space. Imagine if you are building, like, if you're a chondroblast, you're building stuff. You're building extracellular matrix. So I'm a cell here, and I'm putting stuff up around me. Eventually, if I keep putting stuff around me, I'm going to encase myself. That's what these cells have done. They were once chondroblasts. Once they fully encase themselves, they mature into chondrocytes. So it's cells surrounded by white space, or lacuna, surrounded by extracellular matrix. They've enclosed themselves in. They've created themselves as like little caves, tiny little pockets, with no exit. There is collagen in the extracellular matrix, but you don't see it. It looks very glassy. The word hyaline, I'm forgetting now. It's either Greek or Latin. I think it means glassy. Yeah. It is the most abundant one. So you find it on the ends of your bones. You find it for most of your nose. Your growth plates, which we'll talk about. Your rib cartilage. That's what costal means. Costal means ribs. Your rib cartilage, costal cartilages, hyaline. When you look at it under the microscope, if you see lacunae and just a glassy, even extracellular matrix, it's hyaline. Yes?
So would that be the cartilage like around the knees?
Yeah, the cartilage, well, around your knees, like and covering one bone, covering another bone, you have hyaline, but in between the menisci, that's actually a different type.
So if you were to twist your knee,
It depends.
if you tore something,
If you tore a meniscus, it's a different type of cartilage, which we'll talk about. But if you're talking about the ends of bones, that's it's capital bone. All right, our second type of cartilage is called elastic. So there's elastic connective tissue, which has that waviness all in the same direction. There's elastic cartilage. This is different. And of course, as the name implies, it has elastic fibers also. And chondrocytes and lacunae, but you can see that the extracellular matrix looks very different. It's got wavy and branched. It's got wavy and branched elastic fibers in addition to the collagen and water and all that stuff. It's very elastic, as the name implies. Elastic tissue is great for bending and recoiling. It's found in very specific places. Your ears are floppy because of elastic cartilage. Your epiglottis, the epiglottis you saw in the fetal pig, that's elastic cartilage. One other place is the auditory tube. That's the tube that extends from your throat to your ear. So deeper. 3 places. Very limited areas. Fibrocartilage or fibrous cartilage. This has your chondrocytes surrounded by wavy fibers in the same direction. Elastic is branched. Fibrocartilage is wavy in one direction. You find this. This is very dense. It's the densest, strongest of the 3. Elastic is the weakest but most flexible, and then hyalin's in between. This is found in intervertebral discs, so between vertebrae. These make up the menisci in your knee. This is what holds your bone together. Your hip bone. Cartilages. Sorry? And the weakest. Elastic is the most flexible. Like if you tear the fibrous tissue, no pericardium. Which means it's not gonna, there's nothing to regrow it. So if you tear it, it's torn.
So they're already in the spot.
Time and there was some, I guess there had to be a pericardium start, but it's not there. There's no pericardium. Okay, so this is just showing where you find all those different cartilages. Hyalin's most abundant on all the joints, ribs. You only find fibrocartilage, elastic cartilage is for the ear, and the epiglottis. Those are the main ones. Here's what I'm going to do. We're going to try to cut off the bridge of cartilage.
Yay.
If you open up at 53, to come to class on Wednesday with a rough draft. Each person needs to come with a rough draft. You'll notice that there are 8 topics here. Hair growth, nail growth, nail production, hair growth. Draw some kind of diagram, some kind of informational diagram on a single page. Hair growth, hair grows from the main level of detail. Whether it's microscopic, so come with rough drafts. Hair groups, groups. Hair growth, nail growth, production, here. From your back, super reduction and acne.
Okay.
The goal is to be as specific with your label.
Can you fill out the arms?
Stairs
Yeah.
and then turn right.
All right.
I'm like a whole 80% sure it's in there.
Okay.
Yeah.